Good morning, everyone. Today's topic is point defect in Ionic crystal. This is second video regarding to imperfection in solid. In first video, we have learned about that one is point defect in non-ionic solid, or either you can say non-ionic substance. So today we will study point defect in ionic crystal. Okay. Now in case of point defect in ionic crystal, it is classified into three types. Okay, one is stoichiometric defect. Now one is stoichiometric defect. Now second is non-stoichiometric defects, and next is impurity defect. Now first of all, we'll study in detail that one is stoichiometric defect. Acha, your pronunciation, either you can say it's a stoichiometric defect, someone is saying it's a stoichiometric defect, but this one is stoichiometric defect. Okay, now in case of stoichiometric defect, first of all, okay, you should know what are stoichiometric compounds. Okay, actually stoichiometric compounds are those compounds in which the ratio of positive and negative ion is same. That type of compound is known as, okay, same means either it's a 1:1, whatever is the ratio, but ratio is similar, means number of cations and anions are equal. Okay, now in this compounds, if in these compounds there are some defect, so that type of defect is known as stoichiometric defect. Now just see, when the ratio of the number of positive and negative ions, that is the stoichiometry of the crystal, is not disturbed, means even if there is a removal of positive or negative ion, but the ratio will not disturb. Okay, for example, very general example. Okay, now suppose if 10 cations, okay, and 10 anions are present in a compound, suppose it's a very general example. Okay, now 10 so means if you will cut, the ratio remains 1:1. Now suppose one cation and one anion is missing, so it becomes 9:9. Okay, but if you will simplify it, the ratio is 1:1. It means the stoichiometry is not disturbed. Okay, so that one is known as, that type of defect is known as stoichiometric defect. Okay, now in this one, again, in case of stoichiometric defect, it is of two types. Okay, again it is of two type. One is Schottky defect and one is Frankel defect. Okay, both the defects important for your competitive exam as well as for your board exam. Now just see this one. First one is, okay, Schottky defect. Now Schottky defect is a type of vacancy defect, you can say. Okay, now because in this, now just see its arrangement: A positive, B negative, A positive, B negative. It's your wish. You can take X, Y, Mn. It's totally your wish. Now A positive, B negative, like this. And just see, here two vacancies are there. Means it's a cation vacancy because one cation is missing. Here it is anion vacancy because one anion is missing. Okay. Now, but just see, the number of cation and anion vacancy is same. It's 1 is and 1. Okay, so this type of defect, when cations, equal number of cations and anions leaving their lattice site, okay, without disturbing their stoichiometry, so that one is known as Schottky defect. Okay, this one. And again, because again the cation and anion are leaving their lattice sites, so it means they decreases the density of the crystal. Now just see in this example. Okay, it's a NaCl, KCl. Actually, this type of defect is generally possible in those compounds when, okay, the size of cation and anion is almost similar. Okay, it's not exactly same, but almost similar. Now just see, it's a AgCl. Sorry, this one is NaCl, KCl, AgBr, KBr, etc. Okay, all these will show Schottky defect. Now second one we have, that one is a Frankel defect, and this one is a type of interstitial defect. Now but this one is in ionic solid. Now this defect, now just see, again it's a crystal, A positive, B negative, A positive, like this. Okay. Now some of the cation, okay, leaving their space and goes to the interstitial site. Interstitial site means it's an unoccupied space between particle. It's a vacant space. Now just see, some of the cation, okay, leave their site and goes to the interstitial site. अपनी lattice site छोड़ के कहाँ चला गया? That one will go in interstitial site. That type of defect is known as Frankel defect. If you will see, now just see. Okay, now in this one, okay, now check. One cation leave their lattice site and goes through the interstitial site, but overall there is no difference in the density because it remains inside the crystal although it occupies interstitial site, but there is no change in the density of the crystal. So in case of Frankel defect, simple, when cation occupies interstitial site, okay, that one is known as Frankel defect, in which there is no change in the density. Okay, now this one is possible. Okay, this type of defect generally found when anion is much larger in size than cation. When the size of anions are more as comparison to cation, then Frankel defect is possible. Okay, for example, it's a AGBr, ZNS, AgCl, AgI, etc. Because here the difference, the size of anion is larger as comparison to size of cation. Now in this, okay, very one important thing is that AGBr shows both the type of defect. Okay, it shows Frankel as well as Schottky defect. Okay, thank you.